First, I'd like to thank conference organizers for such a great opportunity. I'm really a pleasure to be here with you guys today. In my talk, I'm going to talk about our recent paper published about influencing social networks. Social networks are nowadays very popular, right? And they are at the center of our life. So there are some people who are more influential than others. So in this project, we propose a new model to find who are more influential than others. And this is my outline. First, I will talk about some introduction about the problem and our methodology and then the conclusion. First of all, networks from data science perspective, how do you see networks? Networks are actually different type of data sets, such as text data in the previous talk. But in the network data, we are representing relations between objects. And we use vertices for representing objects, and then and we use edges for representing relationships. So there are a lot of real-world examples. Of course, the first one comes to our mind is social networks. A social network is nothing but a network data. What are the vertices? Users are the vertices, right? And whenever there is a relation, such as friendship relation in Facebook or following relation in Twitter, or like relation in Instagram. So all those different type of relations can make RAs. But of course, social networks are not all the networks. There are biological networks, very popular also nowadays. So for example, this is a protein-protein interaction network. So what are the vertices here? Proteins, right? And then what are the edges? So for example, if two proteins attack at the same part of the body, we put an edge between them. And as you see, there is a very complex.
There's a laser.
Oh yeah. As you see here, there is a very complex structure going on there. There are financial networks. I was working with the bank of the Swiss bank. So for example, customers can be vertices, right? And then whenever two customers purchase the same product, maybe use the same credit card or use the same type of loan, we put an edge between them. So as you see here, networks are very, very common nowadays. And wherever there is a relation, we can create a network out of it. And of course, in the previous cases, I always talk about pairwise relation, right? There are two objects. For example, there are two users in social network. They are actually friends of each other, but this is somehow limited. So that's why in our case, we are going to talk about also pairwise relation. So beyond pairwise relation, sorry. So interactions can occur in group of three or more vertices, right? So interaction does not have to be pairwise. In those cases, we are going to use hypergraphs. So graphs and hypergraphs. So we again have the vertices, but now we have hyper edges showing that higher order interaction. So for example, as you all know, right, co-authorship is not a peer-wise relation. So when we publish a paid article with maybe three authors, there is a higher order interaction there, right? There is a multiple relation. So co-authorship can be a hypergraph. For example, there's even one article, right? An article with one author. This is still possible. So, and there is also target interaction networks. Drugs are vertices. Drugs are vertices, and whenever they have the same targets, we put a high pressure between them. And there are text networks as well. Words are vertices. Whenever they make a sentence together, there is a high pressure over there. Okay, let's talk about our problem. What is the influence maximization problem in social networks? As I said at the very beginning, influence maximization problem is to find the users, key users actually, that will maximize the spread of information. And that information could be information, or it could be an idea, or it could be a product. So all those type of excellent spread can be used in influence maximization problem. For example, this is a email network of a company. So wherever two actually people email each other, we put text between them. So these are the most influential users in the company based on our algorithm. These are actually mostly higher level admins in the company. But if you look at our traditional network diffusion model, information diffusion models, we will see some limitations there. For example, they assume that this influence is spreading uniformly along the ages, but this is not the case. And they also neglect users' attributes. For example, if a social network user is a female or male, or older, senior people or younger people, it all changes, right? But they don't consider those differences. And more importantly, in the classical diffusion models, there is a consensus over time. So as time passes away, everyone agrees on the topic. But this is not realistic, right? So there's an example here. This is a randomly generated graph, and then colors are showing support of a specific topic. For if it is closer to blue, they are supporting. If it is closer to red, they are not supporting the idea. In the classical diffusion model, if I run the model, what happens? Eventually, they all actually come to a consensus in the classical diffusion model. But this is not realistic, right? Nowadays, we see a lot of polarization in the network, in social networks, in our community. So that's why current traditional diffusion models, information diffusion models on networks are not actually capturing the whole story. So to address this problem, we are going to talk about a new data structure, which is called sheaf data structure. Again, we have the graph structure at the bottom part. As you see here, these are vertices and these are edges. But over each vertex and edge, we add data spaces. These are mathematically actually vector spaces, but I will call them data spaces. And then each data space over each vertex will carry about information about that vertex and that edge. So, and after getting this sheaf data structure in the previous slide, we are going to take those data spaces over vertices as opinion spaces, and then data spaces over edges as discourse spaces. So people will have some idea, and then they will discuss each other through edges. And this is a nice example for that. For example, this is an opinion space over the vertices. Let's say the topic of discussion is vaccine usage. As we all know, this is a very controversial topic nowadays. So, for example, and each user has different priorities, right? And discussing vaccine usage. Some people take religion and politics as their opinion basis, as their motivation to decide whether to use vaccine or not. Some other people can take risk-taking and health, right? Maybe their health is more prior to them, and they don't want to take a risk. So what I'm trying to say here is, on a specific topic, each user would have different motivation, right? Different opinion bases. That's why these opinion spaces over vertices are capturing that. For example, over here, the first user for the vaccine usage takes religion and politics as its opinion basis. There's a two-dimensional data space over here. And the second user takes health and risk-taking as his opinion basis. There is another two-dimensional vector space over there. So that's why we can use these vectors of the data spaces over vertices as modeling the user's characteristics. And what about over the edges? So this is another story, right? So sometimes we can have some private opinion by ourselves, but when it comes to disclose our opinion, we may disclose it differently, right? Maybe we are from an A political party, but if we are friends with a political party of B, we may not openly disclose our opinion. So how we disclose our opinion can be also different, right, from our use in our network. As the discourse space over ages, this is possible. So basically, for example, this user on the right is lying to his neighbor on the left, but he's truthful to his neighbor to the bottom part. So basically, before that, right, in the classical diffusion model, this wasn't possible. Everyone is honest, and they just disclose their opinion as their private opinion. But this is not the real case. That's why this sheaf data structure is allowing us actually to represent these different user dynamics as well. For example, same example, right? Same data example. Remember, this guy was supporting the idea, and all other people had different opinion. As the time goes, in this diffusion model, as you see here, there is no consensus anymore. There is a clear polarization. There are three different groups with supporting, and there is one big group mix of supporting and not supporting. That's why this sheaf data structure is allowing us to have more realistic information diffusion on social networks. All right. Okay, let's talk about our problem. But to exit, we applied this idea to different setting. The only setting I'm going to talk about today is the Stack Exchange and Quora, so crowdsourcing forums. Nowadays, people use those blog pages a lot. Some people post questions, some other people answer them. But the question is, who is the most expert people on those blogs? For example, if there's a blog of data science, and there are some specific topics, machine learning, Python, who are the most influential users in these areas? So, first of all, you represent these platforms as graphs and hypergraphs. What are the nodes? Nodes are actually users, of course, who are asking questions, and edges are whenever users interact with the same post, either asking or answering, we put an edge between them. As you see here, there is user one is asking this question in this post, user two is answering, user three is answering. That's why, and in another post, user three is asking what user four is answering. That's why we get this graph structure over there. And similarly for hypergraph, again, we have the same users, but now we put a hyperage for one post only. Okay. And how we apply our shift data? Remember, over the vertices data spaces, we had opinion bases for the users. In the vaccine example, it was politics and religion, right? But in this case, we take those question tags as opinion bases. For example, user one is right, dealing with a question that has big data and Python as the question tag. That's why we have those as their opinion bases. Similar for the question user 2 and user 3. And then we also look at the thumbs up. Those thumbs ups are also important, right? Whenever we ask or answer a question in Stack Exchange, people are voting us. So we use those thumbs up to define how they are disclosing their expertise to the network. And then eventually, our model is able to find who are the most influential people for each tag. Okay, so as I said, okay, how are we going to evaluate, right? So normally Stack Exchange, have you guys used Stack Exchange before? Yeah, there is a reputation score for each user. Some people are trying to target those, right? Getting some medals, gold medals, and some other stuff. So we use that reputation method as our ground truth. So our goal is to make our methods as close as possible to the reputation method of Stack Exchange. Okay? And then what we use for evaluation metric, we use of course correlation. We just rank people from most expert to least expert and look at the correlation between ours and the Stack Exchange reputation method. And we also look hits at n method. That is nothing but looking at the top 10 people, for example, and finding the percentage of the hits between our method and Stack Exchange reputation methods. And then, of course, we also compare our method with some other graph-based methods. PageRank, maybe you heard about PageRank. This is the famous Google search algorithm. So whenever you Google something, it uses this PageRank algorithm to find the best match websites. And we use also two other methods that has been used in traditional setting. And our data set is actually, we chose intentionally different Stack Exchange from different topics. So, for example, we use astronomy, biology, operational research, and Latin. And we took their most observed tag, most common tag. So, for example, in astronomy, it was observational astronomy, and so on and so forth. And we run our data set. So these are the number of vertices, number of edges, number of hypereds, and so on. Okay. The first one is correlation. Remember, we are trying to find a correlation between our method and stack exchange replication method. By the way, stack exchange replication method is so complicated. They are using a lot of statistics, number of thumbs up, number of thumbs down, comments, and that's why it's not actually easy to calculate. But our method is very easy. We are just using the graph structure. As you see here, this SL is Sheaf Laplacian R method. When we look at our graph and hypergraph models, our method is finding the best actual correlation between those two exchange replication methods. And if you look at hits at n, remember finding the top n people, and then n actually is the x-axis, so top 10, top 20, top 30, and so on and so forth. The purple one is our method. As you see here, in most of the cases, again, our method is finding expert people better than other methods. And these are the area under those hits at n graph, and we can see again our method is outperforming other methods. And then we apply similar idea for healthcare. I only have one slide for the other project. This is another paper. 5 minutes. Okay. Usually I can program 11, so I'm expanding. Okay. So basically, for example, in this case, our goal is we have a network of medical doctors who are most, for example, experts, dermatologists in the healthcare system or cardiologists in the healthcare system. So again, what we did, our opinion bases are actually those specialties each doctor has. And then we just look at the shared number of patients between those doctors and create our sheet data structure based on that. And actually, of course, I didn't provide any result, but our method is able to find who are the best, for example, cardiologists or some other specialists in the healthcare network. And another project, which is again published this year, we looked influencers. As you all know, right, there are social influencers nowadays. Companies are hiring them to promote their items. So how can we find best influencer for a specific product? We studied, for example, different type of influencers, and our model is able to find the best influencer. So let me conclude. So as the conclusion, as you see, Sheaf Laplacian, our methodology is offering very novel multidimensional opinion dynamics, which is more realistic and able to capture the dynamics of the information diffusion very well. And of course, after finding the influential diffusion, it also helps to identify the influential users in the network. And then we applied this to cross-sourcing forums, also healthcare forums, and so on and so forth. And our future goal is we want to investigate Sheaf Laplacian to other domains, such as social media analysis and online communities, to understand the dynamic behaviors and influence propagation better. All right, that's all. Thanks so much.
Thank you very much. So this concludes the presentation session of our event. So let me stop this. And then I will open the floor for questions. But I want to give you, since this is an interdisciplinary conference, there are a lot of terminologies probably not many of us are familiar with. So in my notes, I try to take notes, and I use some ChatGPT to make it easier for my understanding. And I will start with the questions of my own for each speaker, and then hopefully then you will have your questions. So Andrew, can you hear me?
Yes.
Okay, so I want to start with you since you were the first person. So I understand you talk about like your main theme in the entire presentation is the privacy concern, right? So
Yep.
are you saying that with the AI or with the emerging technologies right now, like machine learning and everything, the agencies or the institutions are indirectly, not willingly, revealing identities or information too much when they release or share it with the public. And what are we afraid of in this case?
Well, obviously for certain data, like medical research data, it's imperative that it be anonymous so we don't expose other people's medical information. But like if it's not done properly, even if you remove like all the identifiers, like the name, address, social security, everything, you can still be identified is kind of the point, I guess. But like right now, like there that hasn't been any like major like sort of like reconstruction attack or anything, but like obviously we're worried about the future and like as you said, like with AI, it's only going to get easier to sort of reconstruct or re-identify this vulnerable data.
Okay. All right. So in your presentation, I take that, you mentioned about the calibrated random noise. That was the definition of the randomization, right, in your study.
Yeah.
And then you're saying that basically this thing makes it harder for such, revealing or making the identities of the individuals.
Yeah.
Okay, all right. Just keep in mind, I'm not questioning you. This is not a, interrogation. You're just responding very
Yeah,
short.
yeah, of
Thank
course.
you. Okay, I want to move on to Dr. Akbaş's, presentation on the forecasting networks. So you mentioned about the events, and I'm curious about the definition of the event, like because you gave examples from the countries. Are we talking about social events? Are we talking about political events? Like, what is the definition in your study of the event?
Event, like my data says, some of them are protests, like the political events, social events, or some of them are news events, or some health, like COVID-19 outbreaks, disease outbreaks. It can be anything that we can get information from news or social media.
So using that information now, the forecasting the events, is it, good thing for the governments to use your study like to predict certain events to control, or is it good thing for the public to understand this is about to take place?
It's good for public and government also, right? The government goal is to help the public. So when we make early prediction about the protest, like if it is especially the dangers or some terrorist events, so they can take some precautions. Or if it is health related outbreaks is coming, they can take some early things they can do. So it's good for everyone.
But who's going to use that? Like, who's going to use that ability? Do you think like institutions, mostly governmental, public institutions, or like I'm trying to understand the utilization of your study in real life implication?
Actually, anyone who wants to predict the events can use, but in social cases, yeah, government can use, or some public agencies can use.
Or corporations, probably.
Corporations, so health agencies, like to do some for early vaccine prediction or like producing that.
Okay.
They can do early predictions and use that.
All right. Thank you very much. So again, Çetin Kaya, the future, doctor. So, again, congratulations. This was a good presentation. I know you didn't have the end results. It's still in progress. So you talk about the LLMs, forecasting tasks. So could you elaborate more on the machine learn, language models like forecasting, task? What do you define the task? Like what kind of task are we talking about? And that's why I was just curious when I heard events versus task, like how is that different? Task versus events.
Well, we're fine. This has to be all one. We obviously would, what a task. So out of the user, they use the system.
Mhm.
Say you're you're a load forecaster, company's giving you an input, and then I want you to produce an output. And then we train that model, using 3 years worth of data. And then we ask them to kind of forecast the next year's worth of data using the trained, fine-tuned algorithm.
So this brings perfectly to my next question. I knew you were going to say similar to that. So did you use the AI models to develop a reasoning logic model?
Pretty much, yeah.
Pretty much,
Yeah.
right? That was basically the essence of the study. So in this case,
Yeah, so the agents were kind of used to kind of build I guess you can call them prompts
Yeah.
or the fine-tune algorithm. So there were about 4 stages that I used and then the other one on top of that. So
Eh,
the fine.
and for the company ERCOT, in Texas, it's one of the large and energy, utility companies. So what does your study hopefully in the future mean for industry-based companies like, ERCOT or other?
Yeah, I mean, as we all know, electricity is very, inelastic. I mean, like, for example, in 2021 February, when the old, cold front happened, they can have very drastic,
Mhm.
results for everyday people. So this model kind of, provides a way of incorporating unstructured textual data into traditional forecasting methodologies, which aren't currently being used. Like the models that Arcot is using, for the most part, they're statistical models that can't really incorporate the crucial unstructured textual data that I personally saw, financial institutions use for predicting, price movements and so on. Because ERCOT is an independent market, so you can't trade, based off of, future demand. So like, this model can be used by the grid operator, it can be used by, power generators, for example, like power plants, they can kind of, so they have to commit to the day ahead, power generation a day before. So they can be used by them, they can be used by, hedge funds, by financial institutions, who want to have forward strategies or different types of, trading strategies and so on. So it's very versatile in that sense.
Okay, thank you very much. All right, and my final question for the Dr. Akbaş. I know you talk about Sheaf Laplacian. I hope I pronounced it right.
Yes, sir.
But and I think in the simple layman terms, it's about how things are spread in the network, right? That's what
Yes.
basically again, I try to understand, I'm a database guy, but that's not my field. So, and when you say also information diffusion models, it's basically in other words, it's the mathematical formula of mouth of a word, like who said what, when, in what context. But my question is actually when I was listening, and I like that kind of studies. I did the ISIS and their network in the use of the words in their journals and magazines. So, and how do you establish the most influential influence? Is it by the numeric, like the frequency of the interactions? Because you said that there is a complex model, the stack exchange reputation model is not easy. They use several. But in your case, like, what was the main criteria like you were looking at?
Yeah, actually, that's a great question because one of the problems in our area is how are we going to define what is most influential, right?
Yeah.
So there are different ways. For example, stack exchange is doing some reputation score by just looking at thumbs up, thumbs down, number of comments, number of likes they get. But in our case, what we do is when we model the diffusion, what we do is we just look at other people's opinion. If other people's opinion in the network is changing a lot, that means initial seed user, that user is more influential. So basically, depending on the opinion change in overall network, we measure that.
Okay, and do you think in the next round of the study, you're gonna add another criteria for measurement or?
Could be, yeah, yeah. We are also working some other metrics to decide who is more influential. But yeah, these are the techniques that has been used a lot in our area.
And is the data available in such numbers? Because I know you use like thousands of data.
Oh yeah,
Oh,
that's right.
I was kind of surprised to have such a large data set in your possession.
Yeah, small one actually. So
Really?
with social networks, if you think Facebook network, there are 2 billion users, right, with Facebook. So it makes 2 billion vertices with multiple billion edges. So graph data set is actually by nature so huge. Our data set was actually small ones.
Okay, thank you. All right, those are my questions. Just a preliminary, floor questions. And if you have any other questions, please welcome to ask each of the, the panelists.
Hi, my first question to Andrew, actually. So, you presented the like overall solution is randomization, but I just want to point out finding true randoms is also challenging because if you are aware, like a lot of random number generators start with a seed number, so but they are not really truly random. So if there is a seed in the beginning, that's not truly random. So we just need to take this into consideration, I guess. And my second question is about second president, Dr. Akbaş. Could you elaborate on the SS? Okay, yeah. You want to say something?
Andrew, did you understand the question?
I'm sorry, what was the question again?
The question is, do you plan to take into consideration about finding true randomness, like finding in applying randomization? What should be your source for your randomness?
I'm sorry, I can't really hear it. Hear
Can
clearly.
can you hear? Can you?
Yeah, basically what he's saying that, even the randomization is not actually randomization. There's always a starting, point.
Right.
And so would you, take into this, consideration, when you are doing your calibrated random noise argument, like, what would you want to say about that?
I mean, yeah, obviously there's no true randomness, right? When you generate numbers from a random generator using like a computer, it's all like pseudo-random, but ultimately this shouldn't really matter because like the point of the random noise is that the potential attacker doesn't know exactly how the noise like like what the attacker won't know your like seed or your like algorithm for generating random noise. So hopefully they can't like reconstruct the noise if you understand what I'm saying.
So what you're saying is basically you're trying to make it harder, not impossible. I mean, it's impossible, but you're trying to make things complicated for the companies, to reveal such identity of the individuals or the names.
Yeah, and in essence, yeah, like it is obviously it's impossible to truly make it random, but it's practically impossible. Like same way, like if you use like a random password generator, if if a hacker is trying to hack into your account and they don't know the exact like algorithm used to generate your password, there's like practically infinite possibilities, so they can't really like brute force your password. It's this similar idea.
Okay, thank you.
My second question is, Dr. Could you explain more about your assessments, like how you come up with the accuracy?
Like in the event or not. So the collective needs are like we are selecting some events and also the news about them, like 7 days before that event. And also some random events that random news that there's not important events. So with that one, we design our model, we train our model with some of them, and then we create some test data sets like for given any needs, whether it will detect as an event or not. With that way, I mean, like,
So the further, like you only try to do this 7 days, right? So like if you have 15 days, that will make your prediction model better.
like in
The longer the period.
At some point, it's increasing accuracy, but depends on the event. For some events, just the 5 days it start and then just occur. For some of them, maybe 1 month before there is something coming up about that. So depends on the event type. We should decide how many days before we should look.
All right, thank you very much. All right, any other questions, guys? Just one last question, and then we're gonna wrap this up.
For your news, like before an event, your resources are diverse enough, or if you collect your news about some specific groups, might be totally different number, but if you try to collect from other possible opposition, that might be giving another perspective. So how you make sure that you are collecting from diverse resources? And the second question is, your resources only text-based resource, or is also video? These days, the YouTube and other video resources are also maybe more influential than just the text-based, because there are a lot of filters in the text-based information.
The question actually, for the first actually, we didn't collect. We use the collectiveness, but I think that's not depends on from where we collect. Because our goal is not predicting the bias or any political things. Just we are predicting whether there's an event or not, there's a protest or not, or there's an outbreak or not. So from wherever we collect needs, that will give the same results, I think. But yeah, we just use the text in our model. It's of course, yeah, good to use some video or image. But our goal is just using even text. That's giving good information us about events.
All right, I want to thank everyone, the panelists, speakers, and for your participation for this beautiful, event. Let's give a, applause to participants.